Today, or this morning, I want to look at continuous delivery and some techniques that I've been using for continuous delivery with Maven in particular. So these, it's real world techniques, real world tips, nothing too theoretical or fancy. It's really just a few ideas and techniques that I've been using in practice that you may find useful. My name's John Smart. I work in Sydney, Australia. I do a lot of work in continuous delivery, continuous integration, test automation, TDD, or the technical side of agile development. And as I may have mentioned today, I want to talk about continuous delivery. So I'm assuming if you're here, you'll have some vague idea of what continuous delivery is. Yeah? No? No idea? Never heard of it? So continuous delivery is really quite simple. Continuous delivery is about getting interesting stuff in front of your clients as fast as you possibly can. And why do you want to get it as fast as you possibly can? Simply so that you can have a faster feedback loop. So if you've ever used test-driven development, you'll know that the real value in test-driven development is not the fact that you're writing tests, it's the fact that you get a really fast turnaround, you get a really fast feedback loop. So you get an idea, you see if you specify something that will prove that it will work or not, you see if it works and you continue. It's a very productive way of working. Continuous delivery is that on a macro scale to some extent. So it's really an approach that is all about feedback. But there are a lot of things that come into mind when you talk about continuous delivery. Some people will say, okay, you have to use a particular build tool or a particular build pipeline tool or continuous delivery tool. Some people will talk about continuous integration. Yeah, there is a relationship, obviously. Some people say you'll need to use this particular testing tool. Some will say you'll need to use automated deployment. You might need to use Chef or Puppet for your automated deployments. So continuous delivery, from my point of view, it involves a lot of that stuff. But that's not the essential element. It's actually more an attitude. It's more a way of thinking that enables you to put business value in front of your customers as fast as possible and as smoothly as possible and as frequently as possible. And from there, you need tools to support that activity. You need a certain build pipeline set up, so you're going to need automation, you're going to need to automate your deployment process, you're going to need all that, but a particular tool is not continuous delivery. Continuous delivery is the approach that you're trying to implement. So when you're talking about putting value in front of customers, so my wife's a medical physicist. So what they do is basically they figure out for cancer patients how much radiation, or actually how to deliver a certain dose of radiation into a particular area of the body. Now, if you were to apply continuous delivery in that scenario for a new piece of software in the medical industry, I wonder if it would work. So you say, okay, this week, guys, we're going to deliver a feature. You can deliver radiation to any point in the body, but the actual dose is fixed. Yeah? Sure, doctors would be really happy with that. See, continuous delivery is not necessarily about delivering a fully functional piece of software at every release. You can also, depending on your software, that can be useful. Gmail works brilliantly. Other applications that may not be so practical to deliver a fully functional iteration in each time. Maybe it will, maybe it won't. But continuous delivery is still applicable. It's about getting feedback. So if you can deliver a particular feature and show the users how it works at a very regular, smooth interval, it's going to be much easier to adapt and see whether that's applicable. And then when the time comes, it's going to be much smoother to actually deliver all the features you need into production. So feed value can also come in the form of feedback from the user. So you don't want to neglect these concepts just because you're not in a position to deliver a new version to your clients every week. You can still be in a position to, you want to get into the position where if the client is ready, if the client says, okay, we want this new version, it's cool, we're ready, you want to press a button and put it into production. That's what continuous delivery is about. Means that at any point in time, you press a button and the latest working release, there's always the latest working release, the latest working release goes into production. That's the essence of continuous integration, continuous delivery. So on the terms, as opposed to continuous deployment, now continuous deployment is more something that you might see in places like Google where every legitimate release does go into production. Continuous delivery is a little bit different. It means that a release that passes all of your checks and quality controls is ready to go into production, and it can go into production. You have the means to put it into production if you want. So that's the sort of fundamentals of what continuous integration is really all about. So, in a nutshell, we've got a few principles, a few fundamental concepts. Every build is a potential release. So that means that every commit can generate a release. And that also means that a release is not something you decide after the fact. A release is because a particular commit passes all the tests and passes all the checks, it is a potential release. So this is where Maven will come into the picture. Another important aspect of continuous delivery is that you cannot have continuous delivery if the QA department takes 6 weeks to test the software after you've built it. Yeah? I mean, you can automate your build and then deploy it to staging and then, okay guys, we'll test it for the next 2 months and then we'll let you know. That's not continuous delivery because, it's not very continuous. And it only gets delivered as far as the QA department. Now that often happens in large organisations, and that is a problem because that slows down the process significantly, and that is an organisational as much as a technical problem. You need to be able to eliminate those sort of big chunks of delays in the pipeline. The other big area of delay is the actual deployment process itself, where often in large organisations the deployment process, going from taking your application into a development environment, is totally different from the one that goes into the production environment. So that's the whole DevOps scene where trying to move those two worlds a little bit closer. When you have a whole different way of deploying into production as you would do as a developer, it makes it much harder to do continuous delivery. Often in those cases there's a lot of steps that could be automated but that are manual. Scripting, database backups, what have you. A lot of bottlenecks on the deployment front. So that's another common area where you want to try and eliminate bottlenecks. And the way to eliminate bottlenecks is automate the heck out of it. So automate as much as possible. And this is really, I can't emphasize this enough. If you don't have confidence in your tests, you cannot do continuous delivery. Can't even do continuous integration for that matter. You really need to have a high degree of confidence in your tests. I'm not talking about test coverage, I'm talking about having confidence in your tests, which is much harder. It's easy to have high test coverage. It's harder to be confident that when all of your unit integration and acceptance tests pass, your code is ready to go into production? How many people could claim that when all your tests pass, you're ready to go into production? A few? That's sort of what you want to aim to get at. It's easier to do if you start from the beginning, if you do it at the start of a project and take a fairly disciplined approach to your automated tests. You do acceptance test driven development, BDD, TDD, whatnot. That makes it easier. But it's very hard to do continuous delivery without having that degree of confidence, because if you don't, then it just falls into the lap of the QA guys and they have to do all the tests behind the scenes. And it's not only developers who have to be confident, it's also the QA guys, and that's actually quite hard because they think you're putting them out of a job when you automate the heck out of their acceptance tests. You're not, but they think you are. So they'll go and, when you set up this process for the first time, they'll go and do all their manual tests anyway. And you'll still get your 6 weeks, even though you've got all your automated tests. So that's a culture change as well as a technical change. So moving on to the more technical side of it, one of the fundamental things in continuous delivery is the idea of a build pipeline. So how do you actually build a release and shunt it through the system till it gets into production? So this is a fairly well-known concept. So you start off with a commit of some kind. You're going to compile it, build it, run your unit tests, deploy it somewhere, run some integration, acceptance tests and whatnot. Maybe you'll deploy it to QA and you deploy it to prod. That's a very, very simple one. The key things to take away here is that, as I said, each commit that goes into the system can potentially be a release. So there's no process of saying, okay, this snapshot is ready to be released, let's build a release, let's cut a release from this snapshot or from the head at this point in time. In continuous delivery, each commit can be a release. So it's a radically different approach to the traditional approach where you have snapshots which go in then become releases. They are sort of incompatible, as we'll see later on. Other thing is you use the same binaries right through the process. So it's a fairly well-established best practice. They like to say best practices, but best practice that you take a binary. If you can take a binary and then deploy it anywhere, that is a much nicer practice than having to rebuild the application for each platform. I don't know a lot of places who still rebuild for each platform, but there are a few. But it's obviously much nicer if you have a binary and you just deploy it anywhere, and even better if you have the binary, you deploy it to the platform using exactly the same process. So next stage is your acceptance test. So you got unit integration tests before then, but the acceptance tests are the things that are visible to everyone. So the acceptance tests are what give the QA people confidence, as well as yourselves, developers, that the code actually does what you say it does and that the code does what the client wants it to do. So the acceptance tests are really important. Functional regression, whatever you want to call them. So you want your acceptance tests to be repeatable. You want the same set of acceptance tests to run against any platform. Potentially a subset when it runs in production. You don't want to do too many updates in the production system. The clients get stroppy about that for some reason. So sometimes you'll have a subset of smoke tests that will be executed in the production environment, but the principle is you have the same tests that can be run anywhere, and the same test suite, the same build job that applies across the board to any platform. So now the fun bit. So, who's using Maven? No, that's a dumb question, isn't it? Wouldn't be here, well, otherwise would you? So, continuous delivery with Maven, it is actually quite tricky because a lot of the concepts in Maven date from before continuous delivery became popular. And so a lot of the fundamental ideas in Maven are diametrically opposed to the fundamental ideas in in continuous delivery. But that does not mean you have to go back to Ant. God, no. No, you wouldn't want to do that. And you don't have to move to Gradle either, though you could. Gradle will make things a little bit easier, but still Maven has a lot of advantages, so you don't want to abandon it, throw the baby out with the bathwater and so forth. Let's have a look at what the actual issue is. So with Maven, you've got this very useful concept called the lifecycle. So Maven lifecycle, when you run Maven test, it will both compile and run the unit test for you. If you run Maven verify, it will compile, test, package, run your integration tests, and run anything that you've bound to the verify phase. If you do a Maven deploy, it will compile, test, package, run the integration tests, verify, and deploy. Yeah? That's fine. Now the advantage of that is that you never forget to do anything. So if you do a Maven install or deploy, it will not let you not run the unit tests. On the face of it, that's a good idea. It does, but we'll see it has problems when you want to break that process up into a build pipeline. The other hurdle that we have with Maven is the release process. So the Maven release process is based on the principle that you work on a snapshot, you work, then you say, hey, this snapshot's really cool, let's release it. And you use the Maven release plugin. Who uses the Maven release plugin? Yeah, so pretty much everyone. So you use the Maven release plugin, which is quite convenient because it does a lot of the boring stuff that you'd normally have to do manually. It does a lot of checks. Make sure there are no snapshots. Make sure that all the tests runs the tests, creates a new tag for you, runs the tests again, builds it, commits it, runs the tests again, and so forth. So the problem in a continuous delivery context is it does things a lot. The other problem is that the fundamental concept is that you say, okay, I've got this snapshot that's ready, cool, we'll take the head at this point in time and we'll build a release from it. Hopefully no one's changed the head since you've decided to do the release. So, in a nutshell, the release prepare does this. Creates a tag with your new version number, creates updates the version number, and away you go. The perform then goes and does all the checks that we were looking at earlier and redoes everything. Compile, test, package, integration test, verify. How long do your integration tests run, people? Less than 10 minutes? Whose full test suite runs less than 10 minutes? Less than half an hour? Less than an hour? More than an hour. So if you're running Maven release process and the tests take more than an hour, how long does the Maven release process take? It takes a long time. That's one of the things that annoys me about it. Sometimes you do actually need long tests. More than an hour, that's starting to get a bit really long, but that happens with big applications, especially when you've got acceptance tests and they are actually doing heavyweight stuff. You've got web tests, you're doing serious testing, and if there can be quite a lot of it, it can take time to run. So sometimes there's no way of shortening it up. Not every application can be entirely tested with unit tests. The user does not talk to an application through unit tests. The user talks to an application through the user interface. And if you want to demonstrate that an application works, you need to demonstrate it through the user interface. So you need to do web tests a lot of the time. So sometimes there's no way of avoiding that. The tests will take time to run. But that cramps your style. In the continuous delivery approach, that really slows you down. And again, as I keep mentioning and reiterating. There is this fundamental disconnect between the fact that in continuous delivery, any commit can be a release, but in Maven, you say, okay, looks like it's good. Let's build a release. So that means you've got these snapshots, which are nebulous concepts, which don't have any relationship to what's going to actually be released. Then you build from some particular snapshot, and that is your release. So my fundamental issue with, which annoys me with Maven, the Maven release process and continuous delivery, is really that you don't get a potential release from every snapshot, from every commit. What you want with Maven is, what you'd like is every commit can say, okay, this commit, we're good. It's passed all the tests, it's a potential release. And then let the client choose. Let the business choose which version goes out. Is that making sense? So that's, in a nutshell, and the fact that there's a huge amount of repetition, because when you do a release process, if your tests take an hour to run, you run them 2 or 3 times to get a release out. And if something goes wrong, all hell breaks loose. So it's wasted effort rerunning your tests each time when you've just run them. So it's, you can streamline that process a lot. So let's have a look at some options that we could use to make it work a bit better. So often what you'll see is things like this. First stage of your build pipeline, you have Maven test. You have a second stage with Maven verify, which will run code coverage and stuff like that. No, well, actually integration tests. And then you'll run a Maven site for the code coverage. That's not really very efficient. Maven site is really, really slow. You don't want to run it as part of your build pipeline because it's hideously slow. And often you don't really need everything that is in it as part of the validation process. So your build pipeline, sort of like Agile documentation. When you're talking about documentation in an Agile process, you want to know why you're producing a particular document. In a build pipeline, the same thing. You want to know why you're doing a particular task. Is it contributing to pushing the build through the pipeline? So code coverage, does that contribute to pushing through the build pipeline? Only if you actually check whether the code coverage is significant, which we'll look at later on. JavaDoc, does that contribute? Maybe, maybe not. Maybe it's just documentation that you want to do as a separate process off the build pipeline. The Maven site, I don't think the HTML is going to be of much use to the end user, and it's really slow. So generating all that is not something you want to do as part of the build pipeline. You want to be much more selective about what you put on the build pipeline, and have anything else like the Maven site. If you really want to do Maven site, you do it off on another as another build job. And Maven already, as we saw, already does all this in a nice staged manner. So you don't want to have separate build jobs for unit tests, integration tests and whatnot. Do it all in one go. So just do a Maven install as your initial build. That will compile, run unit tests, run integration tests, do any checks that you want to do and so forth. That will do them in the right order, and if it fails, it will fail early. So that's effectively what you want. You don't need to split that part out of the build pipeline. So let Maven do its job where it can do its job well. So the only tricky bit here is this bit, tests and integration tests. Who knows how to split tests and unit tests and integration tests in Maven? Who does not? I'm glad I put these slides in then. So there are many, actually 2 or 3 very easy ways to do this if you're not adverse to 50 lines of XML or so. Effectively what you have to do is find a way of identifying unit tests and integration tests, whether it be by a package convention, a naming convention, an annotation, and then you filter the test you're going to execute at each phase. In a nutshell, that's what it is. So if you're using the Surefire plugin, by default here we're saying skip true, so we're skipping all of the unit tests by default. Then in the test phase, here we're excluding, see this line at the bottom, excluding anything in a package called integration. So here we're using a package-based convention, that anything in an integration, in a package called integration is an integration test, so you want to skip them in the unit test. You could also obviously do that by a naming convention. If you use the failsafe plugin and call all your integration tests something, something, something IT, it'll do that for you. You can also use the categories. The latest version of JUnit, you've got this thing called categories, where you define a hierarchy of interfaces, and you can say, okay, these tests are integration tests, and these tests are unit tests, using annotations, and then group them using exactly the same principle. But the important thing, so this is just an example, it's one way out of about 3 which are very viable. I usually use the Surefire, the failsafe plugin, but if I was doing a new project, I'd probably use annotations because it's kind of nice. There are several ways of doing it. The important thing is you want to make sure you are splitting the unit tests from the integration tests, so that if it fails, if unit tests fail, it fails fast. Once the unit tests are done, then you can start with the slower integration tests. So that distinction is really important. If you make that distinction, then you can get away with just having signal pass build as the first part of your build process. Another thing you want to be careful of is Maven deploy if you've got multi-module projects. So what Maven deploy does is pushes the jar files or the WAR files to your repository manager. Yeah. So when you do Maven deploy, it will go and push things out to Nexus or Artifactory or whatever you're using, and you're all good. But the problem with a multi-module project is that this doesn't work very well, because if you have a multi-module project, it will run the build sequentially. It will run your first module, it's all good, deploys, runs your second module, it fails, it doesn't deploy. So your repository ends up with a mixture of versions. So that kind of sucks. So another approach is you do your Maven install, and then, well, you deploy the artifacts after the build. That's the essential bit here. If you're using Artifactory and Jenkins, Artifactory has a very nice Jenkins plugin where you can deploy the artifacts after the build to any repository you want. So that works quite nicely. If you're using Nexus, you can do the same thing at a Maven level. You do Maven deploy, but as a separate step, after everything builds correctly, you do the Maven deploy. So the important thing here is you're separating the deployment from the actual building the modules. Otherwise you get inconsistencies in your repository. Another important area, so actually all of this is eliminating waste. You're trying to eliminate repetition and waste in the pipeline so you can get it as streamlined as possible. So I'm a big fan of code coverage. It depends when you ask and how you ask. I use it a lot, but I don't use it alone. Ask me later on about code coverage. I could talk for an hour on code coverage. But the point is, if you're doing something like code coverage, using something like Cobertura, you're on Maven, Cobertura. Problem with something like Cobertura or Clover, they're the two main ones that do this. So we'll generate instrumented jar files, rerun your tests with the instrumented jar files. So you rerun your unit and integration tests or whatever. So you're duplicating the whole process here. So in the integration test phase, you run all your integration tests, and then you rebuild everything with with instrumentation, and you rerun them. That's kind of slow and clunky. So for code coverage, my strategy at the moment for avoiding this sort of duplication is using a thing called Jacoco, which is a anyone heard of it? Yep, few. So it's a code coverage library which uses dynamic instrumentation. It doesn't actually mess with your jar files. So you can actually run code coverage on your normal jar files, which means that you can actually bind the code coverage to the normal integration or post-integration test phase, and then just run code coverage in your normal build. That doesn't take a lot more time. So you can do things like, as I was saying, code coverage, anything is only useful in a build pipeline if it helps you push the binary through to production. Code coverage only helps push through to production if you actually do checks on it. The HTML reports are not going to help you know whether, well, they will, but you have to look at them. There's no automation in an HTML report. So the only use of code coverage in a build pipeline is when you decide that it's going to be significant and you don't want it, you don't want less code coverage than a certain level. So you're going to, in your Maven build, or, well, this is the way I do it with Jacoco. In the Maven build, you set up checks to specify the minimum amount of code coverage that you consider acceptable. And then, when you run Maven install, it runs the code coverage at the same time as everything else, and it adds a very minimal overhead as far as time goes. So this normal build versus build with Jacoco, as opposed to twice that if you had to do both, if you had to do it as a separate phase. So you're just halving a chunk of time there to when you include code coverage in the main build process. So that's quite nice. Another approach that we've been talking about is to reuse the same binaries right through the process, which is something that is difficult to do with Maven out of the box. You have to do a little bit of magic. But conceptually, here's what you want to happen. You run a build, it will generate a version. Now the version, you notice, it's not a snapshot, it is a version. It's got a number. Then you're going to deploy that to a test environment, run your acceptance tests, deploy the same binary to UAT and so forth. So again, this is different from the traditional Maven approach where you have a snapshot at this stage, where you normally build a snapshot here. If you build a snapshot, you can't push it through the process because at some point you have to actually cut a release, because there's no way you can release a snapshot into production because it's not reproducible. The build is not reproducible. So you need, at some point, to have version numbers. So my approach is to get the version numbers in there as early as possible. We'll see an example of how to do this, but rather than using snapshots, get version numbers for each build. Another thing, now we've got unit and integration tests in the normal phase, but I put acceptance tests as a totally different module, or actually a totally different project technically, because it's a module but it's not part of the aggregation. So acceptance tests are totally separate and they're parameterized so that you can run them on any platform. So you pass in a parameter, tell it where to go, where to test. We'll see all this in practice. And as I said, if you're bothering to do any sort of code quality metrics, then be serious about it. The HTML reports are not going to help you push a binary through to production. If you're serious about check style, then break the build if there are violations. Same thing for PMD or find bugs. If there's a rule that you don't like, then get rid of it. Change the rules to suit your environment and then make them enforceable, make them break the build if it fails. Or you might do find bugs or PMD, there are levels of violation. So different levels. You can say everything from a certain level, certain severity up will break the build. But come up with a policy and apply it. So any code quality metrics in a build pipeline are useless if you're not enforcing them, if you're not actively breaking the build. So this is why the Maven site approach doesn't really work. You want to actually do something a little bit more proactive, a little bit more selective, and actually invoke the plugins individually. So if you want PMD, do PMD check. Find bugs check, check style, and so forth. And then configure those plugins to suit your environment. So that's easy enough to do. It's well documented, but the point is you want to enforce those metrics actively. You want to be serious about what you're asking people to do. And if you don't, as I said, if you don't like a rule, just drop the rule. Configure it so that a rule that you don't agree with is not applied. You only have a subset of the rules that you're interested in that you think are significant for your situation. And now how do we actually do this version number that I was talking about? Don't use the Maven release plugin. Maven release plugin, it does very nice stuff, but it's clunky as hell and not really suitable for a continuous delivery environment. It drags down a continuous delivery pipeline, makes it hard to. Because if you're using Maven release, then what you have to do is do the Maven release, because you can not do it this way. You can do the Maven release, but you have to do it as soon as you go out of the first phase. So any commit does a Maven release. But that's slow, especially if you've got 1 hour tests. Because you have to do the whole process. And the point is you don't know if you're going to go right through because maybe the integration test will fail. So if you do a Maven release and you're not sure that everything's good, you're going to waste a lot of effort going through that release process if you're going to fail at the integration tests. But if you do a snapshot, you've gone through all that effort, but then you have to go and create a version number and do it again. So what we do is developers work on snapshot versions, that's fine, but as soon as it gets into the build pipeline, you give it a version number. Not with the Maven release process, you just give it a version number. Maven versions plugin. And the version number is effectively, well, this is the way I do it, the first two digits are the real version number, then it's just a build counter. Once you get your build counter, that is the number that goes through the process. So each version goes through, some will result in binaries, maybe some won't. If the tests fail at some point, you won't get a binary. If the code coverage is not sufficient, you won't get a binary. If everything is good, you will get a binary. If you get a binary, then it's ready to go into production. That's the theory of continuous delivery. So rather than going through the whole snapshot up to a certain point, then redoing it all with the Maven release, you start off with a version number, you take it through the process, and if it works, it works. If it doesn't, then you drop that version number. So the key is just not really caring about the third digit in the version number. So in practice, what are you going to do? When a commit comes through, create a new branch. So I do it with Git. You create a new branch. On that branch, you update the version number, you build. If it works, you push that branch back and deploy the release candidate. And if it doesn't, you just drop the branch and you're good. So This is why this works brilliantly with Git, because it's very easy just to create a local branch and then drop it if it fails, and no one will know any better. So in practice, we're going to use Git, create a branch, use the Maven versions plugin. So the Maven versions plugin is a very useful plugin which lets you set the version numbers in your POM files from the command line. Very easy to use. Then you go through your normal process, do the Maven verify and whatnot, and if it works, as I said, you push it back. If it doesn't, you drop it. So it's actually quite a simple process, and you can add as many controls and checks and constraints along the way as you want. And also, one thing I like to do is I use the Build Pipelines plugin. Who knows about the Build Pipelines plugin? A few people. So it's a very nice little plugin for this sort of thing, which lets you visualize a sequence of build jobs and where particular commits are at in a sequence of build jobs. So now I have as I sort of promised in the description, there is a live working version of this. May or may not trust the network. What I'm going to do is I'll take you through I took some screenshots of this beforehand, so I'll take you through the screenshots to show you the highlights, and then at the end, if we have time, I'll show you the real live version in a browser. So this particular demo, fairly arbitrarily, so I'm using Git and Jenkins. They're my tools of choice for this. Running Source Labs, so running the acceptance tests, web acceptance tests remotely on Source Labs, deploying to Artifactory, and running the environment, deploying the actual binaries to the application to Gelastic servers. So Gelastic, I would have used CloudBees because they have a nicer Jenkins plugin, but I had some technical difficulties. That's really not important, because the important bits are the Git and Jenkins here, and to some extent the Artifactory, so where you're actually putting your binaries. But the rest, how you actually deploy, you're just going to have to figure that out for your specific environment, obviously. But the general principles still apply. So what do we got in practice? We've got a set of build jobs. Got an initial build, code quality build, which does the PMD and check style and so forth. We deploy to test, run the acceptance tests. If that works, we'll deploy to UAT, run the acceptance tests. And if that's all good, at some point we can manually deploy to production. So the deployment to production is a manual step where the business chooses to deploy a particular version. So that's the distinction between continuous delivery and continuous deployment. So the initial build, what's special about the initial build? See, we've got our release candidate numbers here. Anything else? So each build has a a build number. That's the number that we assign to it at the start of the process, and that goes right through the process. Where since we're using Artifactory here, we can actually link to the binary. But we'll see there are two. When you're reusing these binaries, there are two approaches. You're going to deploy your binary to Artifactory or Nexus or whatever you choose to use. You could either reuse it from there, or if you're using Jenkins, you can just copy the binary and reuse it from that build, which is a lot simpler, which is what we do here. So that's just where the binaries are actually at in Artifactory. What else have we got? The actual build number is parameterized. So why are we doing that? Well, we might want to change that. We might be building a series of 1.1 builds. So we can just adjust that as we go, and the actual build, the last digit is what we're interested in. Here, first thing we do when we come into a build, so we use Git, we check out that the right one? No, that's not the right one. We're creating a new branch. I've got the wrong screenshot. Should be there's a step before that, which is we create a new branch in Git. Using the interesting bit here, as you can see, we've got some $major version number, $build number. So we're using those parameters to create a new branch, and then this is actually the second phase, and then we'll check out that branch and work against that branch. So it's actually really simple to do. And once we're in that branch, we can go and do Maven version set to update the version number, build the binary, and then we use the conditional plugin called the conditional build step, or something along those lines. You'll know it when you see it. Conditional build step plugin, that's the one. If it works, so if the build succeeds, then we'll go and commit those. These PDFs will be online, so it'll be on the Java 1 site and on the Wackaleo website as well, and on SlideShare. So these slides will be around. So then you push the branch back to the repository. If it's successful. If it's not successful, then you just delete the branch. So it's actually quite simple. The trick is creating a branch right at the start, assigning a version number dynamically from the build number. So you notice we use the build ID, which is the variable that Jenkins uses to identify the build job. So you can use those variables in the Git statements, and then it's quite simple. So then once we've done that, we deploy it to Artifactory. So here we're using the Artifactory plugin to deploy it there. If you're using Nexus, then you just do a Maven deploy. Then we'll deploy it to our test environment. So here we're deploying directly, the end of this phase, if everything goes well, we actually deploy directly to test. You could do that in a separate step as well if you wanted. So here, just for completeness, we were using Gelastic, so we had to set that up as a Maven job. If you're using CloudBees, there's a Jenkins plugin, which makes it a bit easier to do. If you're deploying to an internal Tomcat or something like that, there's also the deploy plugin. Or you can just use, if it's really custom, then you just use some sort of scripting to do it. Here, the point is you figure out how to automate the deployment. This is just nice to have. I'm using the build description setter to go and look through the log files and figure out what version I'm building, and then put that in the description of the build so I can easily see what version is being built. And then this is important. Archive the artifacts that you build. We're going to archive them because, as I said, in this particular pipeline, we're going to reuse that binary right through the process. We're going to copy it from here. We're not going to get it from Artifactory. Just because it's easier to copy it from here. I'm lazy. If you get it from Nexus or Artifactory, then what you would do is you'd take the build number that we just created as a variable, pass that into the Maven job as a parameter, and have a parameterized dependency, so a variable in your dependencies. So that works too, a bit more complicated. And then, so here's the next bit. We use the parameterized build job to trigger the next build step. And here we're passing through this release tag. So we're passing through the tag that the build version that we're working on at the moment. So that's what ties it all together. That's what ensures that at the next step we will be working against the same commit, working against the same branch. So right through the pipeline, we create a branch, we work against that branch right till we get our binary, till we've validated our binary. I had to do this, so block build when downstream project is building. I had to do this because you could conceptually do it differently, but in this particular setup, we've got a test environment, a UAT environment, and a production environment. When you deploy a version to a test environment, you don't want another commit coming through and deploying it to the test environment while your acceptance tests are running. That would be annoying. If you wanted things to be really streamlined, then it would be conceptually not too hard to do to actually create a new environment each time. But I don't know whether you'd really want to do that. It would depend how keen you were on streamlining things. So then, next stage, we move on to the code quality build. So this is where you do your PMD, you find bugs and so forth. And on the other side of the coin, so we passed in the parameter, the release tag. Here we're getting the release tag, and we'll go and use that. Again, the Git plugin is really useful for this because it's quite easy. You can, is it working? Sort of. Down here we've got the $release tag, so we're going to check out the branch that we're currently working on. And then it's the rest is pretty easy. So deploy to test, you just do exactly the same approach. With one extra thing, we need to get the binary we want to deploy. So where do we get it from? We use the copy artifacts plugin, so we copy the binary from the initial build, and then that's where it will just deploy it to the directory that it came from, and from there we could just do a normal deployment. So it will be in a target directory. You can just run use the normal way you deploy your WAR file. So here we're using the Maven Jelastic plugin, but that's not really important. The point is you've got your WAR file, you've got your binary that you built originally, and then you do what you want with it. So reusing the same binary, which is the important thing. Another interesting bit here. Now remember I said use the same test suite to test each environment. So here, another thing you can do with the parameterized build plugin is actually effectively call a build job. As opposed to trigger a build job, you call one as part of your build job. Sort of like a sub-build job. So here we're actually invoking the acceptance tests build job, passing it in a parameter. So here it's parameterized, so we say, okay, run it against this platform. So the parameter that the acceptance tests platform takes is the acceptance test build job is the platform that you want to run it against. And that allows us to do both the acceptance test. You can test both the test environment, the UAT environment, the production environment, and so forth. So this is the same build job. You've got one build job that runs acceptance tests, pass in a parameter, and test different platforms. So there's nothing really particularly complicated here. And the actual build job, we're just running a set of acceptance tests. What are we doing here? So using that platform to build up the URL that we want to test and passing in the URL that we want to test against. What else do we do? Yep, seen that. And the last thing I want to show you is another approach that I took for the actual deployment into production. I just wanted to show you the build promotion plugin. So the build promotion plugin lets you define, actually, did we do that earlier? Yep, here it is. Here we go. Build promotion plugin lets you define an action that you want to do when the build achieves a certain status, or when you manually say this build is good to deploy. So here we've got a deploy to production promotion. We say only when manually approved, so we say this is a manual promotion process. And what do we actually do? You write down the bottom, we say project to build, deploy to production. deploy to production. So what that effectively does is that in any build job, so you can go into a build job and say, okay, deploy this version to production. Click on the approve, and that will actually deploy it to production. And to tie it all together, we're using this build pipeline plugin. So what the build pipeline plugin does is looks at the structure of your build jobs and creates a model where you can actually see the sequence of builds. Works, it's not perfect, it doesn't handle every situation, it has a bit of trouble with joins and things like that, but for a case like that, a typical build pipeline, it does a pretty good job. So here we've got the green means those build jobs have passed, red means we've got some failing build jobs, yellow, there's one in action at this point in time, and then blue hasn't been done yet. So that gives a nice vision of where the build pipeline is at. So that's pretty much the overview of the process. We have 4 minutes left, so what I think I'll do is open it to open the floor to questions. Yes?
Yeah, about every commit that you do, would you agree that it sort of requires you to have ubiquitous as like Git or Mercurial? Because if you don't, you can have developers that are terrified of making a commit because they're afraid it's going to be what they build and it will go through. So what can happen is that they don't commit, finally make a monolithic commit, and of course the build will break. So what do you think? Does this require DBCS, or can you just also run with SVM or whatever?
I would prefer to do this with DBCS, with Git or Mercurial, just because it's more streamlined as well. Because creating branches in Subversion, deleting them and whatnot, you're actually doing it on the server, so it's clunkier and much more visible. For the question of whether developers are afraid to commit because they're afraid it goes into production, I don't see that happening that much. What you do, but you're right, one of the advantages of something like Git is that you can obviously work locally, do your commits. What I do, often I'll just commit for every unit test that passes. I'll commit so I can roll back if I need to, and then when I'm ready to push, I'll group those commits together, squash them all together, and that makes it much easier to do meaningful commits. That's one of the big advantages of something like Git.
So what's the advantage of building a new branch every time you want to push it through the process? Anyways, you're going to be using the same binaries through the process. So
Yeah.
you want to create a new branch.
The create new branch is more for, because you've got your acceptance test as well as your source code, so you want to make sure everything is synchronized and everything is working, and for order traceability you want to have that branch created at some point in time. So you want to create the branch as a reference, and so it could be a tag. Conceptually it's sort of like a tag, but you want to create that at the start just so you can have a reference to it. Any other questions? Yep.
Could you comment shortly on code coverage? I'm sensing you're not so much for it.
I am very for it. I am very for it, but if anyone asks me, I'll come up with all sorts of negative comments because I don't like people. Code coverage is too easy to game. It's too easy to, if you tell a team we want 90% code coverage, they will give you 90% code coverage, but it may be worthless. If you work using test-driven development or behavior-driven development or BDD in general, you will get very high code coverage, and if you get low code coverage, that's a significant danger because something's gone wrong with the process. But it's not because you're trying to get high code coverage, it's because of the way you're working. So I like to ensure that I have high code coverage, but the only metric I'm interested in is if the code coverage is low, why is it low? And then I want to know that the tests are of high quality. That's what gives me confidence, not the code coverage itself. I'm more interested in the lack of code coverage to see why code is not being tested. If code is being exercised by the tests, that does not tell me that it's being effectively tested. Only the tests tell me if the code is being effectively tested. So that's why I'm a little bit, I have weird contradictory comments on code coverage. Yes?
How do you manage multiple projects in Maven and Jenkins? How do you update dependencies? What if there's another team delivering, right? Continuous delivery pipeline behind you? How do you manage that later?
I'd manage it just like I'd manage an external dependency. So I consider internal, for inside the same module using snapshots. Anything external, you want to be using proper version numbers. If you're using snapshots against an external dependency, it's kind of dangerous because it means, you can't do this process. But if all teams are using a process like that, then you just use the latest and greatest release. You update it periodically, but you try and have a bit more control over when you do your updates, just like you do if you're working with Hibernate or Spring or an external library. You consider binaries coming from other teams in the same way as you consider an external library.
Okay, so how do you automatically promote another team's library then?
You don't, you manually do it.
That's contradicting the idea of continuous delivery.
Not really, because I'm considering continuous delivery in the context of a particular project, and the deliveries and the binaries coming into a project from another team. I want to be able to control if they're important enough to be updated each time, then they probably should be part of the actual project. Otherwise, if it's an external dependency, I'd rather manage them independently. Does that make sense?
Okay, so similar Nexus or Maven question I have is, what about all these artifacts that you're delivering to your central repository? Do you really need an all-time process for taking them up and out with Nexus? And it fills up very quickly. If every single release I do gets pushed into Nexus.
Yeah, that's a good point. Would want to clean them up periodically. Or you could even, if that was a concern, then you just do an install rather than a deploy, and you copy it, and then you do deploy at the end of the process when it's all released. Or you can also promote, so with Artifactory you can promote binaries from one repository to another. So you'd have a temporary repository effectively where you could delete old ones and a permanent one. But if that were, what I'd usually do if that was an issue, is I'd delay the deploy task until after all the controls are done. Any other questions? Yep.
You mentioned building with it or generating a number right away as opposed to a snapshot.
Yeah.
So how does that, can you explain that a bit? Because are you actually creating a branch every time, like every commit results into a build number? And is it actually are you updating the form file and checking it right away?
Every commit creates a new build number. So use the Maven versions plugin to update the build number. You create a local branch. If all the tests pass, then you push that branch to the main repository. If the tests fail, you delete the branch.
So if all of them are successful, you will have
Yep.
as many commits you have.
Many branches or tags or however you want to do it. You can do it with tags as well. Tags are actually more conceptually, you have a tag or a branch for every commit that actually passes all the tests. That's the principle of continuous delivery.
How do you tie in SQL to builds?
As in the database side of things?
Right, so I got to do a build that's got these database sort of proc changes used, but
You want the SQL, any of the SQL updates to be stored in version control. That's the short answer. Keeping track of those changes, there are a couple of tools, but I haven't come across a really satisfactory one. The Liquibase sort of works, but it's a bit clunky because it's all XML based. The most effective tools I found are database specific ones to manage change between versions of the database. If you rely on the automated updates that Hibernate does and whatnot, it can be a little bit dodgy. But essentially, or you want to have those, all of the database descriptions in version control as well somewhere. think we'll probably get kicked out soon, so I'm happy to take questions in the corridor. Thank you.